Hi all, my name is Gulshan working as an assistant professor, AI and DS department, SNS College of Engineering. So in the continuation of the previous video, we are here with a new topic called as stochastic games with the unit 3 called game theory. Okay. Now what is called as a stochastic game? Stochastic game is something which involves multiplayers at the same time, and it also involves the scoring process, the methodologies, and the minimum value, maximum value that is being associated with it. So it involves a multi-agent game where players take turns making decision influencing the players current state and future state. Okay, unlike the deterministic state, it does not have any kind of determined way of stating which is the process, what you have to do and all. Now there are essential components that is being involved with the stochastic game, that is set of state, set of actions, transition probabilities, reward function, and the discount factor. Set of state represents the number of possible configurations of the game. Set of action is like the decisions that is being involved by the player. Transition probability is the different kinds of moves and the process that is involved by the player. Reward is the different rewards that is being allocated for the different process and the different games, the different players that he or she is getting reward. What is called as a discount factor? Discount factor is a value which is indicating the reward for the future process. Say for example, if you are playing good in this game, you will be provided with 10 points extra for the next game that you are being played in the process. Okay. Now what is the role of stochastic games in artificial intelligence? You have modeling the multiple agent system, incorporating the uncertainty, sequential decision making, reinforcement learning. Okay, now what is this modeling multi-agent games? Modeling multi-agent game is like you can have different types of games and you can model different types of games that is involved. Now incorporating the uncertainty, you can have different kinds of uncertainty that is being involved in that game and you can incorporate it. Okay, now sequential decision making is you have different decisions and the different decisions that you take then and there is called as sequential decision making. Reinforcement learning, it is something which is closely related to stochastic games and it is also a subfield of AI. Okay, where you can learn the optimal strategies that is being involved. Now when you take this types of stochastic games, there are different kinds of stochastic games that is being involved, that is zero sum stochastic games, general sum stochastic games, and Markov games. What is this zero sum stochastic games? Okay, now in this the games, if one player gain is exactly equal to the other player's loss, one player is winning and the other player is losing, that is called as zero sum stochastic games. General sum is like which is not as like zero sum stochastic games. The playoffs is actually general for both the person and he did not do any kind of balancing out. Okay, now what is this Markov games? Markov games are special cases of stochastic games where state transition follow Markov property. What is this Markov property? Okay, if the future state depends only on the current state and the action taken, not on the previous state. We saw in the belief state, right? Each and every action will be taken as the current state. So it is something which is related to the belief state. Every actions will take the current state as the action process. Now when we are taking this stochastic games, we will be taking this Baghoman problem. In Baghoman problem, you have two different keys, that is black and white. The player will be asked to toss the die. So you will be having two players, right? Whenever the first player throws, or whomever the player is, when or he or she throws the dice with the maximum value, will start the game. Say for example, if you have 12 and 13 and you have 1 and 24 on both the sides, the arrangement of the black and white coins will be same in the process. When if the white coin is assigned or allocated from 13 and 14, the black coins will be allocated at the place called 11 and 12. Okay, this white coins will be moved in the clockwise direction and the black coins will be moved in the anti-clockwise direction. Okay, this is how the process is in the Baghoman game. Now if in case the white key goes and puts his key above the black coin, it will be taken as a foul case, and you will be taking that coin and putting it in the middle of the gaming board, so that you will cut off the process and you will deallocate it. Again you have to throw the dice, and you have to somehow make that die to come in and play the games. So as of now, in this backgammon game, you will, as I already said you, white moves in the clockwise direction and black moves in the counterclockwise direction. Say for example, imagine white has rolled 6-5 in the scenario depicted below. White can choose between 4 valid moves, that is, it can move either from 5 to 11 or 5 to 12 or 5 to 11 or 19 to 25, or it can move from 5 to 10 or 10 to 16 or 5 to 11 or 11 to 16. So say if it is taking the first as 5 to 11 and 11 to 16, the first number indicates moving one piece from position 5 to 11, and the second part indicates moving another piece from 11 to 16. Okay, in this stochastic games, it has different probabilities. Say for example, the blue thing states the maximum value, and the green dot lines states the chances and the minimum value which is being involved. From that minimum values, you have to take different chances from 1 by 36, and that minimum chances, from that minimum chances you can take the maximum value, and then you can derive the terminal process that is being involved. Now in this expect min-max algorithm, you will be following a formula in which you will be taking the minimum value, maximum value, and the different kinds of chance that is being involved in it. So what are all the applications of stochastic games? It is used in autonomous system, financial markets, healthcare, and the security system. So this is all about stochastic game and the process involved in it. If you have any doubts, feel free to contact or to give the comments in the comment section. And yes, as of now, this is the kind of thing which I wanted to explain you. And in the next video, we will see different topics of partially observable games. As of now, thank you.